Hello again, class. Mr. Knight here. Here's part 2 of lesson 2's insights. We're going to talk about software development and testing together. So first, let's talk about the software development life cycle. Process is important, no matter how painful it is. Process is important. As part of this course, you'll be doing weekly exercises with some sort of Python programming, some sort of testing. All of these projects are going to be very, very small, right? You'll be by yourself, working independently. You may have 1 or 2 Python files, no more than maybe a few hundred lines max per assignment. That is not quite like what software development is in the real world, right? There's a difference between programming and software development. When you get into the industry, whether that's working for a company or some sort of government agency or some sort of open source projects become much, much bigger, right? You're not the only one working on them. You have a ton of people, right? Your teams could be anywhere from a couple to a dozen to maybe it's part of a greater organization, right? To tens, even hundreds of thousands of people. About 10 years ago, I worked for IBM. They had 400,000 worldwide employees. That's pretty big. So, and the other thing is not everybody is going to be working on the same things, right? You have different roles. Some people are developers, some people are testers, some people develop different parts, front and back end. So you need good practices for bringing the team to work together in order to produce the desired software product. And that's why we have these methodologies, these development practices that we need to have. Historically, the most popular software development practice was called the Waterfall model. In the Waterfall model, you would do things in phases. You would start with gathering all the requirements for the software product to build. You would move forward to a design phase where everybody thinks about how this thing is actually going to look, what it's going to be, how it's going to be architected, all the ins and outs. There may be some UML diagrams, there may be some magic charts, there may be a lot of documentation generated then. But then once it's designed and everybody agrees, it moves forward to the implementation stage, in which developers will write the code for the product according to the design. Once implementation is done, it gets passed off to the testing team in the testing phase, where people will test it, try to break it, try to find bugs, report bugs back to developers so they can fix it, and just get the product to be good enough in terms of its quality. From the testing phase, it then goes to a release stage where it's the final bits of testing, the final sign-offs, the final performance measurements, building up and putting a nice big bow on top so that it can be ready for general availability. The idea of this waterfall process was that it's mostly like a pipeline, right? You go through phases of the pipeline, different stages. The reason why they called it waterfall is if you imagine a waterfall where water pours down and collects in a pool, and then it pours down into the next one, and then it pours into the next one. That's what the waterfall model is all about, going from requirements to design, implementation, testing, and release, and then repeat. Now, I say this was a historical model. Many places still use waterfall, but it's not in vogue anymore. And the reason why is because it has some serious limitations, right? When you have this very, very lengthy process, it's very, very monolithic, right? You go from one thing to the next to the next. And you don't have that fast feedback loop always coming back. Fast feedback in terms of tests failing and needing to fix bugs. And also with the customer, the fast feedback to know whether or not the customer is getting value out of the product and features that you're delivering. Because in terms of business, you don't want to waste your time and your money building something nobody wants. Also, waterfall could be a little bit complicated. A lot of companies, especially bigger ones, may have multiple release trains happening at the same time. And so those pipelines kind of get layered on top of each other. where, for example, let's say you have a .0 release. And so the development team is working on implementing in the implementation phase of .0. Then as soon as that's done, they'll pass off their code to the testing team for the testing phase. And then those developers won't sit around and do nothing. They'll start working on the .1 features. And so the testers will be testing .0, they'll be pushing bugs back for .0, and so developers will need to be in both the .0 and the .1 code. And so that way it's, these things are stacked so that you can hopefully get things out a little bit faster, but there's a lot of context switching. And the bigger the product, typically the longer the release cadence. I used to work at NetApp a couple years ago, and for the major releases of their operating system, on the waterfall model, it could take 18 months to 2 years just to release a new version of their operating system. Almost 2 years to get something out the door. That's an insanely long time in the software space. So, all that to say, waterfall works, but it's not ideal. And so a lot of companies are moving away from waterfall and moving to something called Agile. Capital A, Agile. You may have heard of this before. Most likely, if you're pursuing a software job, then you're going to be probably joining up, if you're pursuing a software job these days, most likely you're going to end up on a team that's doing something Agile-like. The idea of Agile software development is that we don't want to wait forever for that feedback loop. We want fast feedback. So we want fast feedback in terms of quality, checking for bugs and testing. We also want fast feedback in terms of customers, right? We give them something small. Do they like it or not? Yes or no? Okay, how does that inform the next step we take? So with Agile, instead of having this huge pipeline or this huge waterfall of phase after phase, we do things in iterations. Typically 2 weeks, sometimes 3 weeks, maybe up to 4 weeks. But it's pretty standard 2-week release cycles. At the start of that 2-week sprint, the team comes together, they plan what they're going to do, they size it up, and they commit to their tickets for that sprint, the work that they're going to do. At the end of the sprint, they will have it all finished. It's a bite-sized piece, a small deliverable. So they will have it implemented, they will have it tested, they will demo it to the rest of the team, and then they will release it to the customer. And we stack up these sprints, boom, 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 right after one after the other, so that we are always iteratively releasing new stuff. And if we have a bigger kind of feature that may take longer than 2 weeks, well then we plan that as what we call an epic, where we'll have multiple sprints with multiple tickets lined up as part of that epic, but over time we'll be delivering step by step, piece by piece, little parts of that feature. There's a lot more to Agile than that, but that's kind of the high-level view. It's all about iteratively building, testing, and releasing new stuff so that we can get feedback. The most popular process within the Agile space is called Scrum. Scrum is where you take those 2-week sprint time boxes and you have a whole bunch of ceremonies, which are just meetings with purpose, for things like refining, grooming, planning, meeting between different roles like tester, developer, and business or product owner will come together and figure out what to be done. Demo meetings, retrospective meetings. There's also something called Kanban, which is more of like a continuous flow of work, where you'll have tickets constantly being prioritized, and the ones that bubble up to the top are always the ones that are next to get done. And you basically just burn down your backlog like that. And Kanban is not so much about time boxes of 2 weeks or 3 weeks, but more of the rate at which you crank tickets through. Agile has been around since the early 2000s. There's even something called the Agile Manifesto, which is a whole bunch of thought leaders declaring what they think is best for Agile, and everybody just say, yes, that's what we're doing. You can Google Agile Manifesto and look it up. It's good stuff. right? Because it favors a culture of action and doing the right things rather than doing process for the sake of process. Agile really started becoming popular, I'd say about 10 years ago, as a mainstream software development process, right? In the early thousands, it was more bleeding edge, niche. By the late thousands, a lot of bigger companies, including enterprises, started getting on board with Agile, and that's when you have a lot of good tools come out. You have a lot of people come out. You have a lot of like Scrum Master training programs, and it became the new buzzword. And to this day, most development shops, I would say, are probably Agile or Agile oriented. Though I will warn, in the past couple years, there's been a lot of backlash against Agile because it has been somewhat process heavy, especially Scrum. And what you're seeing now is a lot of companies and teams they'll call themselves lowercase a Agile, or they'll say they're post-Agile, where they focus more on the philosophy and the benefits rather than strict rote processes. So keep an eye out for that. Not every team is going to have 2-week sprints and demos and retros, but most teams are going to have some sort of iterative continuous flow because it's that fast feedback from the iterations that really helps your team out. So now that we know a little bit about software development lifecycle, where does testing fit in with that? Testing is a very, very important component. Unfortunately, sometimes it's overlooked or it's not done quite as intensely or as much as it should be. But testing is really part of the overall development process. I don't like to think testing is something separate where you say, okay, I have my development team and my development work, and then I throw that over the fence, or I change phase and I go to the testing team or the testing work, right? Delivering good, high quality software involves testing as part of the development process, right? You as a programmer, you as a developer need to be able to think how what you're making is going to be used by the end user. What problems could happen? What bad inputs could make it blow up? What are all the different edge cases, right? That is all highly important to the development process. And so the best approach is to have testing baked into the regular process, right? As soon as you develop something, you should put unit tests around that. Make sure that's going. Once you get that going, then maybe you should look at integration tests and end-to-end tests to make sure that not only are you testing the code to make sure that your functions and methods work correctly, but you're also testing the features to say, hey, it's actually delivering the value that the end user needs. Or, when I click this button on a web page, it actually opens up a new thing, that more end-to-end workflow. So testing is very, very important. There are many, many buzzwords to different kinds of testing. In fact, I just threw out a couple of them. So where do we begin with that? What even is testing? How do we define testing? So let's start there. Testing is the process of identifying goodness and badness in whatever the thing is that you are looking at. A lot of times people think software testing is all about finding bugs. That's half of it. Finding bugs is about identifying badness, right? Oh, it blew up, or oh, it gave me the wrong calculation, or it did something wonky that I didn't expect. Those are all bugs, and that's all badness that we're trying to identify. We want to identify that and send it back to developers or fix it ourselves because that will keep the quality high. But something people often forget is the validating goodness. Right? If I have 100 test cases and I run all 100, one of them fails for a bug, but 99 of them pass, that 99 is still very important because what that tells me is that we're 99% good. I can ship this and 99% of the features work. And I know that. I'm not wondering, oh gosh, what else could possibly be wrong? Are these things possibly breaking? I know anything that I've tested that passes is working. I can rest easy at night. I can move faster with other development because I can trust that what I've already done is working. So testing is about validating goodness and identifying badness, both of them together. How we go about doing that testing. There are two primary methods: white box and black box. White box testing refers to testing that will directly access the source code of the product under test. So if you've written that grade calculator and you have your Python functions for taking in all the different grades and then computing the final grade that's a weighted average, then what I could do is I could write a test case. And in fact, we'll be doing this in a couple lessons. And I can write a test case that will call that calculation method with different combos of inputs and then validate that it's returning the right thing, right? That kind of test case is usually what we call a unit test case. It's testing a small piece of the code, a unit of code, so to speak. And it's directly calling it in order to check if it works or not. Right? White box means directly accessing the source code in that pattern, right? And we can test anything in the source code just by calling it, right? That's also why we want to make sure we separate concerns and write different functions and classes and methods for different things so that it can be testable. Because if I clutter everything together in one mega function, I'm not going to be able to test the individual parts. And if I can't test it, then there's more risk when I go to deliver it, and there's more cost when I go to maintain it in the future. So bite-sized piece is good, unit testing, very good, white box testing, very good. The other kind of testing is what we call black box testing. Now, black box testing is when we don't have direct access to the source code. Now you may be wondering, what do you mean I don't have access to my source code? Well, you may have access to it, but the point is that the test is not directly manipulating it. There is a difference between testing code and testing features, right? Code is that calculation function. The feature is the user typing something into the command line and getting an answer, right? The feature is what the end user is actually interacting with. It's what they're actually using. So black box testing is meant to is meant to cover features. That could be something like if you have a web application, can you log in and view your profile? Can you go to Google and do a search? Versus, hey, does this particular JavaScript function return some value? Right. So black box testing tests features. REST API testing, web UI testing, command line testing, those are all examples of black box testing because they're making calls to the application under test. They're not making calls to its source code. So, white box, black box, both important. In this course, we'll start off more with the white box stuff, but then we'll move into black box later on. We will be doing things like REST API testing and web UI testing. So cool stuff. Now, we have these different methods of testing, black box and white box. The next question is, how do I know what I should and should not test? Excuse me. The sad fact is we don't have enough time in the universe to test everything. There are simply too many combinations of inputs, too many ways features can work. It's a combination explosion, right? How many ways can you test Google searching? How many phrases can you enter? How many different links can you click? It's crazy, right? So what we have to do is we have to be picky and choosy with what we test, right? We can't test everything. There's not enough time, there's not enough resources, and also there's not enough value add. So the first piece of advice I always have is focus on key individual behaviors. Just like we want to separate concerns within our code, we want to separate concerns with our testing. Right? A lot of times people will try to combine a lot of stuff into one test case, and it makes this test case very long, very hard to understand, and very prone to breaking. Test automation is very fragile. The more you shove into a test case, the more likely it is to crash. So what we want to do is we want to identify individual behaviors. Behavior is the way in which something works. So if I'm testing something on a website, if I take Google, for example, one behavior could be doing a simple search. Another behavior could be, once I have a search, I click a link and make sure it opens up the next page. Or if I'm already on the results page, maybe I click that images link and then it turns to the image results page. Those are all examples of individual behaviors. Each behavior should have its own test case, because when I run all of these tests together, what I want the test report to tell me is what is good and what is bad. If I have one test case that covers everything and it fails, I don't know which part of that was bad. I have to open it up, dig deep, maybe do some manual testing on my own. But if I have 100 different tests covering all the different behaviors, and 99 of them are passing, I know that's where the goodness is. I know those are the behaviors that work. I can zero in immediately on that individual one failure and very quickly know, aha, that was the thing that was bad. And I don't have to waste time on the rest of the stuff. So separating individual behaviors is good. Another thing we want to do with test cases is identify equivalence classes. Scary word there. What's an equivalence class? Well, let's keep thinking about that Google searching example. If I want to test just basic web searching, does the search phrase really matter? Probably not. It's not much different to search for pandas versus pythons versus elephants versus whatever, right? All of those are animals. All of those could be part of the same equivalence class, because when I search for an animal, I'm expecting to get back results about that animal. And the type of animal doesn't really matter too much, other than the fact is I'm searching for an animal. So we could say our equivalence class is animals, and examples in that equivalence class could be pandas, pythons, and elephants. Right. The reason why we want to identify these equivalence classes is because with an equivalence class, we're saying that we only need one example from that class for a test case. Any additional examples we use in that same equivalence class doesn't add meaningful value to our testing, right? Testing is expensive. Testing takes time. It takes you twice as long to run 2 tests as it does 1. So when I'm talking about hundreds to thousands to tens of thousands of tests that take minutes to hours to even days to run, I need to make sure that I'm not wasting time unnecessarily. So I'm going to run tests using equivalence classes, identifying what are the different categories of inputs that matter, and then choosing one example from each, so I'm not wasting time I don't need to. That's what we mean by equivalence classes. So another equivalence class for searching could be something like maybe programming languages. So maybe we want to have a test for an animal, maybe we want to have a test for a programming language. Maybe we decide the difference even between those doesn't matter, and we just have one equivalence class for search for anything. The job of this tester is to determine what the appropriate equivalence classes are and what the appropriate examples are, right? We want to mitigate as much risk as we can with the resources of time and people that we have. So be smart. There's never necessarily any right or wrong answer. It's more of what's better or worse. And we're trying to maximize the goodness in our efforts. So that brings up another point of return on investment. I've said many times testing is very expensive, takes time, takes effort, takes people, and we live with finite resources, right? I don't have as much time in the universe as I'd like to be able to test all the things to make sure it's perfect. So whenever we write tests, we want to make sure that we're focusing on return on investment for the investment we put in, right? If I'm going to spend a day testing, I want to make sure that that day is worth it. If I'm going to automate a test, I want to make sure that the time I spent developing and writing that test case is going to pay off in terms of it covering important things and finding important bugs. Some tests are just inherently more important than others, right? Typically, your your main features for your application, the ones that the users use more often than anything else, are where you definitely want tests. And the edge cases, the features that very, very few people use, maybe 1 out of every 1,000,000 users happens to stumble upon it once a day, that may not be something that you want to spend a whole lot of time covering. It may not be worth it. So always try to maximize the return on investment for the effort you put into testing, right? We don't test for testing's sake. We don't test so we can have a checklist of did this, did this, did this, did this. Time is money. Companies are trying to maximize their profits. Government agencies are trying to govern. Open source projects are trying to get as much free help as they can. Not as sometimes people are paid to work on open source, but they're trying to get as much help as they can to sustain the project and deliver value to people who are using it. And so, right, testing does not deliver features, right? Testing makes sure the features works. So with testing, we want to just do just enough to make sure that we're good, that we're satisfied with the risks that we've mitigated. We're making sure that there's no scary bugs being leaked out. And then we move on to other things. Finally, the last thing I want to touch on today with our testing talk is test automation. There's a difference between running tests manually and running tests automatedly. Historically, all testing was manual, meaning on a team, you would have to hire somebody to be a tester who would sit at the keyboard and just bang away all day long trying to, like I said, identify goodness and validate goodness and identify badness. They would be running test cases to see, hey, does this work, does that work? And anytime they discover a bug, they would write it up with repro steps, send it to a developer, and keep moving. Testers would also usually formulaically write test cases, put them in some sort of repository somewhere so other people could share. They'd have to go into these tools to report what tests they ran and what tests they didn't. But all this was done by hand, right? They would be using their expertise of the product to do the testing. Then, gosh, probably about, starting about 20 years ago, maybe more like 15, became popular. We had this idea that why don't we develop software to test the software automatically, hands off. That's what we call test automation. Test automation is nothing but software that tests other software. The idea behind test automation is that with a manual tester, you need to have that person do all the stuff. Many of the steps that person is doing are repetitive. How many times do you have to log into the app? How many times do you do a search? How many times do you load your profile, right? And not only that, but how many times do you need to run the same test over and over again throughout a release cycle? And if we want to speed up our release cycles, we need to be able to run all those tests even faster. So if we had some sort of automation that could, at the push of a button, run my test, run it consistently, run it very, very fast, and run it repeatedly, no matter how many times I push that button, then I'm going to drastically reduce my release cycles, and I'm going to greatly increase my coverage with testing. That is the idea behind test automation. It can run tests fast, it can run tests reliably, it can run tests repeatedly. All those repetitive things, let the machines do it, right? The challenge with test automation is that it's software development, right? You need to have people develop that software, and then they also need to maintain that software. And because testing is a moving target, right, the product under test is always growing and changing. That means the tests need to grow and change with it as well. So there's big payoff, but there's much higher investment that a team needs to make if they're going to automate their tests. So that goes back to what I said about return on investment. If you're going to choose to automate tests, make sure they're worth automating. Make sure it's worth putting the effort into making them so that you're actually getting value when you run them repeatedly over and over again. When we talk about writing tests in Python, that's test automation. Right? That can happen at the unit test level, where you're directly calling in a white box sense whatever Python code you've written. That can be black box, integration end-to-end, web UI, REST API tests, where you're using tools like requests or Selenium WebDriver to call out to services and to call out to web pages, and then make sure they're doing whatever and come back and verify. All that we can automate with Python. Python's a great language for it. I love it. But when I say test automation, that's what I mean. We still need to have some level of manual testing, right? We can't automate everything, or rather, we can automate everything, but the return or the amount of stuff the work we'd have to put in would be insanely high to automate everything. So a lot of teams, they'll do a strategy where they'll automate a lot of stuff and then leave a little bit left for manual testing, because some things like visuals or complicated setup are just easier for a human to do and more reliable. So I've blabbed quite a bit about software development and testing. I hope that's a helpful overview off the cuff for the things you're going to be learning in this week's lesson, as well as in this course. If you have any specific questions about software development, software testing, or test automation, feel free, just email me, or you can even put a thread out there in the collaboration in Blackboard so that everybody can see. It could be things like, so Mr. Knight, what's your day job like? Or what are your thoughts on this aspect of testing? I'd be more than happy to answer. So with that said, good luck with lesson 2. I look forward to seeing your assignments turned in. Remember, it will be this upcoming Thursdays when they're due. And happy Pythoning. Catch you later.